Hello everyone, my name is Mosisa Aga. I am a maths professor at Auburn University at Montgomery. In this video, I would like to show you how you can use Excel in finding binomial probabilities, finding normal probabilities, Poisson probabilities, and finding critical z-values, critical t-values, and critical chi-squared values. So let's begin with binomial probability. Now you will use in the function fx, you will see here this function fx. So if you click over here, a dialog box shows up. It will say select category and here on the second row. Now I already selected statistical, but you have a lot of options. So I will select statistical. Then these all functions of statistical are listed here in the drop-down menu. So scroll down until you get binomial distribution. If you scroll down, you will see a binomial distribution. This is binomial distribution. Click on binomial distribution and click OK. Now, remember, in a binomial distribution, there are two parameters. One is the number of trials. The second is the probability of success. Now, let's take a practical example. Suppose that we know that 6% of Americans are millionaires. Okay, so the probability that a person is a millionaire is 0.6, 6%. Now, let's say we pick 50%, 50 people at random, 50 Americans at random, and we would like to know how many of them are millionaires, or what is the probability of getting 2 of them millionaires, or 3 of them millionaires, or 3 or less to be millionaires. So in this case, you have to put here, I'm going to put here n is 15, the number of trials is 15, the probability of success in this case is 0.06. That is the probability of a millionaire. And let's say I would like to know the probability of, among the 15, the probability that 3 or less are millionaires. So I would like 3 here. And this says, in this row, it says cumulative. So if you click over here, it will show you that cumulative is a logical value. So you don't write a number here. You will write instead true or false. Cumulative means if you are looking for 3 or less than or equal to 3, then it is cumulative. So in this case, yes, we are looking for cumulative, and therefore I'm going to put here 3 or less. So true. I'm going to put true. You see, the probability that 3 or less Americans are millionaires will be 0.9896 and so on. So that's how you find binomial probability. Okay, let's say you want to find the probability that exactly 3 of them are millionaires. Okay, exactly 3 are millionaires. So you just put false here, because it is exactly 3 is not cumulative. So the probability that exactly 3 of them are millionaires is 0.04677 and so on. That's how you find binomial probability. How about normal probability? Well, the same. Click here, scroll down until you get normal distribution. Okay, look for normal distribution. Here is normal distribution. I click on here, click over here, click OK. Now remember, in a normal distribution, there are 2 parameters as well. One is the mean, the other is the standard deviation. Now, let's take a practical example. Suppose that the mean height of men in the United States is 69.2. and the standard deviation is 2.9. So in this case here, in the place of mean, you are going to put 69.2, and the standard deviation, you are going to put 2.9, okay? And let's say you like to know the probability, if you pick a man, you like to know the probability that the height of this man is less than or equal to 76. Okay, 76 inches, which is the height of my son, by the way. So it says here cumulative, okay? Cumulative means less than or equal to. So I'm going to say true here, okay? True. So you see the probability that if you pick a person, the probability that the height of this person is less than or equal to 76 is 0.9904 and so on. So another way of putting this is about 99% of Americans have heights less than, about 99% of men in America have heights less than or equal to 76. It also means 1% of Americans, only 1% of Americans have height more than 76. Okay. If you want to find probability that X is greater than 76, you just need to subtract this number from 1. 1 minus this number will be 0.001, 0.01, which is 1%. Okay. Okay, so that's how you find normal probability. Let's talk about the Poisson probability. Okay, click here again. Okay, scroll down all the way until you get Poisson. Okay, Poisson distribution. Here is Poisson distribution. Click over here and click OK. Now, remember, a Poisson distribution has only one parameter, which is the mean. Okay, let's take a practical example. Suppose that the average number of hurricanes in the United States is 6. In other words, on the average from the past experience, people have found out that about 6 hurricanes exist in the United States every year. So the mean is 6. Okay, let's say you like to know the probability that in the next year, there will be 10 hurricanes. Remember, the mean is 6 doesn't mean that every year you will have 6 hurricanes. It simply means that on the average, it is 6. Next year, it could be 10. It could be 11. It could be 2. We don't know. So let's say you want to prepare for the worst case scenario. Let's say, what if 10 show up in 2000 during the next year? So you want to find that probability. Now click here. It says cumulative. Cumulative means you want to find the probability that 10 or less hurricanes will exist in the United States. So you are going to say true in this case, okay? So you see that the probability that 10 or less hurricanes exist in the United States is 0.957 and so on. So it's about 96%, okay? 96%, right? And if you were looking for the probability that exactly 10 will show up in the United States, 10 hurricanes, exactly, then you will have to say false, okay? And the probability of exactly 10 is only 0.04, okay? The probability of exactly 10 is the probability, no, the probability that x is greater than or equal to 10. The false part, I'm sorry, the false part shows the probability, the opposite probability, which is the probability that x is greater than or equal to 10. That is 0.04, okay? So, or 4%. All right, that's how you find Poisson probability. Now, in the same manner, you can find any other probability which is listed in the list. As you can see, you can find any other probabilities using Excel. Okay, next, how can we find z-scores? How can we find critical values? Critical values are z-scores. They are used in finding confidence intervals. Confidence interval for proportion, confidence interval for the mean, confidence interval for standard deviation, okay? So you can use critical z-value, critical t-value, or critical chi-square value. That are what is described in chapter 7 of elementary statistics, or those of you are taking our class, my class. So now, so what is critical z-value? Now let's say, let's roughly draw. I'm using my mouse to draw this. I apologize. My drawing is not very good because I'm using the mouse to do that, okay? I'm not used to writing using a mouse. So let's say, no, I'm sorry, I have to erase this. This is not what I want right now. So let me say, this is a normal curve. You are all familiar with a normal curve, I believe, okay? Let's say this is a normal curve, okay? The critical value Z alpha, what we call Z alpha over 2, is the value of the z-score. The z-scores on this horizontal line, the value of the z-score that cuts area of alpha over 2 to the right, okay? So this is area of alpha over 2 to the right. And this is 1 minus alpha over 2 to the left. So the one which gets area of alpha over 2, 1 minus alpha over 2 to the left. So that is what we need here. You should have 1 minus alpha over 2 to find critical value, z value, t value, okay? Now, how do you find that 1 minus alpha over 2? First of all, you should be given confidence level. I'm sure you are familiar with confidence level. You should be given confidence level. Okay, let's say you are given confidence level of 95. How do you find 1 minus alpha over 2? The confidence level is 95, means our alpha is 10%, 5%, okay? 5%. That is, you can call it lack of confidence, okay? If this is confidence level, it is 5%, or 5% means 0.05. Sorry for my clumsy handwriting. And that is, but we need to look for alpha over 2, okay? Alpha over 2. How about alpha over 2? Alpha over 2 will be 0.05 over 2, which is 0.025. That is alpha over 2. And 1 minus alpha over 2 will be 1 minus alpha over 2 will be 1 minus this number, which is 0.9750. So that's how we found this 0.950, okay? Similarly, given 90%, you can see how you find this. Given 99%, you can find that 1 minus alpha over 2 is this number. Given 98% confidence level, you can find out that the 1 minus alpha over 2 is this number. Now, given that, it's now easy to find, let me erase this first, okay? Let me erase this first. Given this, it's always easy for you to find the critical value. Here is how we do it, okay? Now, click here, okay? Click here and scroll down. We want to find Z. Z is a standard normal distribution, the normal distribution. So go all the way until you find normal distribution, okay? But not normal distribution, but norm inverse. Norm inverse, it says. For the critical value, you have to find for norm inverse. Click OK, okay? Now we already have probability means this 1 minus alpha over 2. That's what we need to put in. For 95%, for example, I'm going to have to put 0.9750, okay? And the mean is 0 and the standard deviation is 1. That's standard. So that is the critical value corresponding to 95% confidence level, okay? Similarly, for example, if you are looking for 90% confidence level, you just need to change this to 95. So if you change this to 95, you get 1.6448 and so on. That is for 90% confidence level. If you have 99% confidence level, this is 1 minus alpha over 2. If you change this to 9950, this is the critical value, okay? Similarly, if you have 98% confidence level, this will be 1 minus alpha over 2. So it is 99.9900. And then this will be the critical Z value. That's how you find critical Z value. Okay. Now, how about critical T value? More or less the same. Click here, okay? And go all the way down until you find the T distribution, T inverse, okay? Look for T inverse. Here is T inverse, okay? Click here. Now, the T distribution is almost the same as the standard normal distribution, okay? It's almost the same, okay? The difference is the T distribution has a degree of freedom. Remember, the degree of freedom is n-1, okay? When n is a sample size. I'm sure you are familiar with that, okay? So you need to have a degree of freedom. That's the only difference, okay? For example, if the confidence level is 95, and I want to find the critical value, T value, all I have to do is put this 1 minus alpha over 2, which is 0.9750 in here, and find the degree of freedom, which is the sample size minus 1. Let's say it is 49, okay? So that is the critical T value, okay? Similarly, if you want to find, for example, 90% confidence level, it's the 1 minus alpha over 2 is 0.9500. So put 9500, and what you get is 1.67 and so on for the T critical T value. Okay. Similarly, for this one, you just need change this number, change this number. If you want, if the degree of freedom change the degree of freedom, and you can find the critical T value. And finally, how about the critical chi-squared value? Again, do the same. Okay. Slightly different here. Let me pull this a little bit up, and let me show you what for the chi-square distribution, we have the right critical value and the left critical value because they are different. For the standard normal distribution, the right and the left, except for the sign, they are the same, okay? So we don't have to find the right and the left separately. But for, because the chi-square distribution is not symmetric, okay? It is skewed to the right. Because it is skewed to the right, sorry for my drawing, that's somewhat the chi-square distribution graph looks somewhat like this, okay? So the right critical value is the value of the chi-squared value that cuts area of alpha over 2 to the right, or 1 minus alpha over 2 to the left, okay? So this is the right critical value, chi-squared. Sorry for my handwriting. Chi-squared right, okay? And this is the left critical value, okay? This is the one which cuts area of alpha over 2 to the left, okay? Here, remember, this cuts area of 1 minus alpha over 2 to the left, okay? This area from here to here is 1 minus alpha over 2, including this area, okay? And this one here, right here, this critical value right here is, I hate to write with this chi-squared left, the left critical value. Now, how do you find the right and the left critical value? Now, let's take this example, okay? In this example, if you are given 95% confidence level, 1 minus alpha over 2, which corresponds to the right critical value, is area to the left, 0.9750. So all you have to do is, let me change this here. All you have to do is go down until you get chi-square inverse, chi-square inverse. This is chi-square inverse. Click here and click OK, okay? Chi-square inverse. Now, the probability is the same probability, 0.9, sorry. I'm sorry about that. 0.9750, and the degree of freedom. Well, I don't know. Let's say the degree of freedom is 51. Okay, so that is the right critical value. Okay, and let's say you want to find the left critical value. For the left critical value, you just need to enter the left area. Okay, alpha over 2. Alpha, this is 1 minus alpha over 2, and the complement of that is alpha over 2, which is 0.025, 0.025. So the left critical value is 33.167 and so on. Those are the critical values. okay? The left critical value is this much, and the right critical value is what we have seen earlier. So in this way, you can find all the critical values for the chi-square distribution, okay? So let me erase this. I hope this video has been helpful. See you in the next video.